In the name of God. Hello, dear students. My name is Masoud. I'm a physics teacher. We are in Fairhua's website to explain the physics curriculum, grade 12. We are in chapter 1. And in previous lectures, we talked about angular displacement. We solved sample problem and practice. Right now, I'm gonna, let's say, start new subject, which is linear speed versus angular speed. Linear speed versus angular. I prepared the, let's say, table for you for comparing between linear and angular speed. Linear speed is denoted, let's say, by V. V is small. Angular speed is denoted by omega. This is called omega, right? It's not W, it's omega. It's a Greek, let's say, letter. The first definition for linear speed is the distance traveled in a specified time interval. Distance traveled in a specific time interval is called linear speed. This is our background. You know what linear speed is, but you don't know what angular speed is, right? Let me read the, let's say, definition for you. Angular speed is the time rate of change of angular displacement. The time rate of change of the angular displacement means delta theta divided by delta t. Number 2, I can say this one angular speed is the corresponding twin for, let's say, linear speed. It's a rotational twin for linear speed. They are, let's say, they are all speed, but this one is linear motion. This one is, let's say, rotational and circular motion, or in general, angular motion in general. Number 2, linear speed is found by this equation. V is equal to delta x over delta t. Time rate of change in linear displacement. This one, angular speed or omega, is found by this equation, time rate of change of angular displacement, not linear displacement. Linear speed V is expressed in, means is measured in meter per second. Of course, in SI, I mean in SI, because we have centimeter per second, kilometers per hour, but they are not accepted in SI. Only this one is valid in SI, meter per second. What do you say about the unit of angular speed? Take it from the rule. Actually, displacement, angular displacement is measured in rad, right? And delta t is measured in second. That's why rad per second is the unit of angular displacement. Angular speed, excuse me, angular speed. We have a note here, angular speed. What do I mean by angular speed? Omega describes how quickly the rotation occurs. So omega describes how quickly, how fast the object, let's say, rotates, right? How fast the object rotates. We have some other notes. Let me read them for you. If delta theta is unknown, so the equation, right? In a question, for example, if question, let's say, needs delta theta. If delta theta is unknown, what shall you do? Actually, you just cross multiply the equation. Delta theta becomes omega delta t. This is the, it's not the new rule. It's just rearranging the original rule. If you memorize this one, let's say you can rearrange it for delta theta or delta t, no problem. But I want you to memorize the, let's say, the original rule. If delta t is unknown, right now delta t is variable. Delta t is unknown. We look for delta t. So rearrange the equation. It will be delta t is equal to delta theta divided by omega. They switch, right? Omega and delta t switch with one another. That's why. And delta theta remains as it is in a numerator. The average angular speed is defined by omega average. That sometimes, actually, in questions, sometimes we are asked to we are asked to find omega average angular, let's say speed. Average angular speed, actually it has the same rule as angular speed. So I'm not gonna, let's say, explain, I'm not gonna distinguish between angular speed and average angular speed right now, because we have it in the next, let's say, lessons. In next lessons, I'm, let's say, focusing on it, and I'll explain it for you. But right now, keep in mind that omega average has the same rule as omega. It's the same. Just add the subscript for omega. That's it. Omega average. That's it. The average angular speed is found by this equation. You see, it's the same equation. The same equation without any changing. Let's discuss some question with you. I'm going to discuss some question with you about actually about this subject. Question number 1. I prepared some questions. It includes some national exam questions actually. Number 1, angular speed omega of a rotating object is defined as what? A, rate at which a body rotates about an axis. It's true, yeah. It's the first, let's say, definition. It's rate. If it said rate, means time rate, so it mentions time, yeah. So it can't be this angular displacement because it says the rate at which a body rotates about an axis. B, time rate of change of angular displacement. Keep in mind that whether it mentions time or does not mention time in front of the rate, actually before the rate, it means time rate. So it mentions time, whether it doesn't mention it. Rate means time rate, right? So it says the time rate of change of angular displacement, it's right, means delta theta divided by delta t. Time rate of change of angular displacement. C, ratio of angular displacement, delta theta, ratio delta theta, to the time interval, to the delta t. You see, it's the same that the object takes to undergo that displacement. It's the same. So all of the options are true. That's the answer. Question number 2, angular speed or omega is expressed in, so it doesn't mention in SI. You see, it doesn't say. Question says, let's say, in general. Rad per second is true. B, rev per second, it can be. C, A and B are correct. Right. D, it says meter per second. Meter per second cannot be because meter per second is for what? This is the unit of what? Linear speed, not angular speed. So, national exam question. I mentioned it here. National exam question, question number 3. The rate at which a body rotates about an axis, usually expressed in radians per second. It gives you a definition for a quantity in physics, right? What's this quantity? The rate, I told you, the rate means the time rate. Whether it mentions the time or not, actually, it's the same. It means the time rate. The time rate at which a body rotates about an axis. The body rotates about an axis. What does it mean? It means it talks about angular displacement, right? Usually expressed in radians per second, and that's it. Which one is true? Is it angular displacement? No, because angular displacement does not have any time interval. This is the rule of angular displacement. Delta theta is equal to delta S over R. You see, it's just an angle. An angle about which an object rotates. That's it. But here it says the rate. It mentions the time interval. Angular speed, till now it's true. But let's say, let's keep reading the question. C, angular acceleration. We have no information about angular acceleration till now, actually. We don't know what this is. Tangential acceleration. what's this? We have no idea about tangential exclusion. The best, actually, not the best, actually, the only answer is angular angular speed or omega. Right? Thank you guys for watching this video. I want you to follow our videos, and bye for now.